Hello, Miss Walsh here. So let's take a look. We are in Rome and we notice that a €2 per table charge has been added to our bill for a certain amount. You also plan to leave a 10% tip. So if you calculate the tip and then add the table charge, then our function would look like this. We would take a value of x, we would multiply it by 1.1, so the bill amount plus the 10%, and then we would take that result and add 2 on it. If you did it in a different order, if you added the table charge and then you would take that amount and multiply it by 1.1, then your function would look like this. So if we express this into the function notation and we define the c as the table charge and we define t of x as the tip, then this is what it would look like. We would take the bill amount, we would put it into the tip function, and then we would take that result and we would put it into the table charge function. And so as you can see, our final result is actually composed of two functions. And that's our topic for today. Our topic is composite functions, so functions that are made up of more than one function, okay? How does this look on a mapping diagram? You remember this? Well, mapping diagram maps a whole bunch of independent variables onto the dependent results. And so we would take our bill, for example, 10, put it into the tip function, and then we'd get 11, 1.1, and then we take that result, put it into the table charge, and we would end up as a final result of 13. And you can do this for any amounts of your bill. Okay, so that's what a composite function is. It's a function that's made up of two or more functions. This is the notation for it. So in our case, this is c of t of x, or sometimes there's a little dot in the middle. So this right here means f of g of x, or sometimes you may hear fog, but that's what it means. It means that we've taken an x value, put it into the g, take the g and put it into the f. This is going in a different order, so this means that this is a g of the f of x function. Okay, so let's apply this to an example. We have two functions. We have the f and we have the g. And the first thing we do is we're going to evaluate our first function, so the inside one, and we're going to start with g of minus 2. And so there's our function. So we're going to put the negative 2 into the g. And that's 4 minus 3, and so that's 1. And now we're going to take this 1. So the 1 is the g of minus 2. And then we're going to take f of 1 and then put it in. So we have 2 times 1 plus 1, and that is equal to 3. Okay, so what we have here is we have the final value, right? So in the mapping diagram, if this was the negative 2, then this would be a result of 1. Take the 1 and get a result of 3. With these, we're not being asked for a specific value, but we're asked for what we had here, just the resulting function of the two together, okay? So f of g of x requires us to take the g and put it into the f. So we need to evaluate f of the g function. Okay, well our f function is 2x plus 1. So this is going to be 2. Instead of the x, we're putting in our g of x. And then there's still the plus 1. And now we just simplify a little bit, okay? So this is going to be 2x squared minus 6 plus 1, 2x squared minus 5. So you're not finding an actual result here, but this is an expression that will get you from an input of x right away to the composite function. Okay, and now you can try, you can pause and try whether you would get the g of f of x, okay? So we need g of the f function. Putting this into the g. Well, what is the g asking with every value to do? It's asking to square it and take 3 from it. So we're going to square it and take 3 from it. Okay, this is already finished. We can just simplify a little bit. So if you FOIL this out, like this, then I'll speed it up a little bit. This is going to be 4x squared. 2x would be 4x. This would be plus 1 minus 3. Minus 2 is your finished simplified result. Okay, so that's composite functions, and you're going to try some here. So the first one is asking you to evaluate this for specific value. So start with the f, put it into the g, and then this is asking you to take the g and put it into the f. Remember the first thing, just rewrite it for yourself as f of g of x. So we're making interesting, complicated functions today. Okay, ciao.